Look at that shader. It's beautiful. I always link the shader for the intro in the YouTube description because like I want to like have the log because it's fun finding a shader every day. It's very cool shader. All right, and get cereal. Cereal. Hmm. Well, do I have any notes about physics bars? Oh, algorithm failure. Hmm. Hmm. Alright. Hmm. Hmm. Oh boy. Mm-hmm. Okay, so does what does this mean? So we this algorithm needs uh relative position between two meshes. So edge vec oh this is verts. Oh. Hmm. Oh. Okay, so the edge verts are on mesh one. And then the mesh zero vert is on mesh zero. Blah. Uh So anywhere it's comparing two vertex positions, it should be mesh 1 minus mesh 0 plus div? Um, but that's not what's going on here. This is both mesh 0, and that's a little bit confusing. Mm-hmm. I think these are misnamed yet again. So yeah, this is vertex 1 and vertex 0, not like mesh 0 vertex type situation. Man, I wish I could half-ass it and like try it out and see like how close it comes. But no, I really have to make a whole algorithm to completion, and only then will I have something to test. Are you still doing this? Jits. Is that British? Doing this with the unibrow. I don't really use my unibrow for activities, you know? That's not really how I consider my programming operations, is the unibrow operation. Hmm. So this stuff is kind of weird because the D value has to be between the edge vertices, but the relative position is affected by the query point. Luigi. I am not picking up what you're laying down. So if it might be, I'm thinking I know what to do here to make it more obvious. So I'm going to do mesh 0 vertex minus edge vertex 0 and plus diff relative position. And then that's the D relative to the... So then this would be 0. Okay, what the hell is going on? Okay, this is like moving across the surface of the mesh. And we found the two closest vertices. Okay, and then we're testing to see if the edges are closer than the vertices. Okay, so I'm thinking D is positive. And then this would totally be just edge n dot edge n. And then edge n dot edge n. Okay, what's diff? Is that this guy? I think that is diff. What is this music? Here's to you. Do you just want the song name or like, what the hell is this music? Okay, then we can grab edge NN as well. It shouldn't be 0. Wait, I typed spaces. No, I've been infected. Where did this come from? Because that's totally wrong. Deref? Come on, bro. Directed. Undirected. Is this real? Okay, where's this variable up here? Only there. So we only want undirected edge. Interesting. That makes sense because we're just kind of like in general testing the edges. We're not like moving across. We did that before here. And you can see in this algorithm, we have all sorts of these directed edges. Oh, directed verts. Okay, that's a bit of a weird function name. Who wrote this? Right, I was gonna rewrite it with like more stuff. I forgot. Okay, so I have no idea if I just made something that makes no sense, but there's code. I wrote it. Wait. No, I'm gonna need to test the faces as well. I can't just give up halfway through. Unlucky. Oh my god, bruh. Okay, V1E. Oh, good. So this is edge verse. So we're gonna have a edge vert. No way. And then Mesh 1 becomes mesh 0. Wait. And mesh 0 becomes mesh 1. Is that it? No. We have this guy. I think it's going to go like this. EV0 minus M1V. And then all of this still works. Diff is in the direction of edge end. So it's like... minus... Excuse me. I don't know. I can't understand it. Okay, so then this guy is over here. Where's... Oh, okay. V1 is from outside. It's from way up there. It's just like way up here. Oh, is that behind my camera? Yeah, it is. It's on the scroll bar. So when I click this, it shows up. And it's way up here. Way up there. Okay, so probably this is probably wrong, but that's okay. It's not too common to go on edges, so as long as I get the faces right, we should be able to like test this and fall through the ground a bunch of times. Let's go. Okay. Okay. Oh my god, I just bit my cheek. Don't do that. That's a dumb idea. Nice code. I'm guessing that's sarcastic. For F1 in not sarcastic. Okay. If you say so. Self mesh 1 dot vert faces. Vert ID is vert1. And this returns a list of 2 faces. Can we asref this straight off? Yeah, let's go. Okay. I'm going to finish this off, and then we'll look at how to do faces. My hair feels funny. Oh, I turned the camera off. What's the hair doing? Yeah, that's bad hair day. Go right back under the headset. Okay, so for each face next to, oh, it isn't an F2 or a list of two faces. The faces could surround the vertex in numerous quantities. So we're gonna have something that's a lot like this, except completely different. How does he make that sound? How does he do that? Bro. Okay, so to start off, we'll grab the face ND. Yep. Do I have to... What? How big is this guy? This is a U32, I think. Yeah. Okay. So we're just gonna steal it then instead of using a reference. Bro, that's sound. Okay. So this is we got the N and the D. Wham, wham, wham. So oh. Must we do face edges? Okay, there's gonna be an algorithm somewhere. All right, let's F for face edges. It probably is in here. So, face edges.
Direct and edge IDs.
So we get the ND. It's gonna look like exactly like this. Well, edges as ref iter enumerate. Boy. Yeah, none like this. And yeah, so we're gonna have bounds, but we're not gonna have a solve. Edge verts. Wait, I just pasted it in the wrong place. So face ID is face 1. Mesh is mesh 1. Oh, and then do we really need to grab the directed edges? This is like, yeah, okay, so yeah. So what's going on is we found the closest vertex to a test point. And now what we want to do is test to see if the test point is over a face. So it's like close to that vertex, but the face is actually closer. But we need to like check if it's within the like perpendicular column that comes off of the face. So the face like defines a column where anything in this area is closest to the face. And it does that by the no, it doesn't. Okay, so you have to use the face normal and cross it with the edge direction to get a perpendicular plane to the face. You cannot use the adjacent face normals because those might not be perpendicular. Like this is a special case, a cube, but if you imagine, here's a relic. Oh look, oh, you can't read that. Nice. I guess I'll keep it on. Oops, keep it on the camera because I'm gonna explain it. So with the perpendicular, the ooh, it's so dusty. Let's use this side. So the column coming off of the face defines where points are closest to that face. So it goes all the way to the corners and it comes out. It's a big rectangular prism. And that's still true if it's like this. But now you can see, so the column is like this and it's not parallel to this face. It has nothing to do with this face. It's the cross product of this face normal and this edge direction. That'll give you a vector that points, well, that'll be like this direction or that direction. And I have directed edges so I can guarantee that they always point either in or out for calculations that depend on that. Yeah, so it works for acute, and it like doesn't depend on the other faces. So ooh, so dusty. Buh. I need to do a deep clean over my whole house, but I don't know how I'm gonna get that done. So I'm gonna call this wait, why is that 0? What the hell? Man, that's so deep. Look at all the queries. I guess they're like all quite cheap. So like vert faces, it just like grabs it off the list. So easy. Faces slice, done. Yeah, okay, so I guess it's actually not that, oh, you can't see what I'm doing. I was looking at these queries. So like within the context of a Minkowski sum, these are like expensive queries and I do them in the name of physics. But this is the setup algorithm, which is supposed to be fast. And it should be fast here because these are cheap for when you know the mesh beforehand. Another one, edge verts. Oh my goodness. Ah! What happened? That's like a Qbox bug. Holy smokes. Did I seriously select text and it started scrolling up and down? Bro, no way. Oh, look at this. So like scroll bar is next to the text, right? I'm selecting text, mouse is down. I hit this. Oh, now I'm scrolling. Bruh. Qbox type bug. All right, so this is gonna look exactly like this. The bound isn't going to change. Wee woo. We're gonna have woo. Oh, okay. I see. That's where it came from. So face, and then vert face. So this is necessarily vert 0 and face 1. This guy is irrelevant. Okay, so now we have to basically calculate the distance to the face, but we must Okay, so this is just a check. Yeah. Does that always work? I think that might always work. So we only need... I keep turning off stuff. Bro. Wait. Squared. Wait. Squared. Oops. What is this dude doing? Oh, okay, there it is. Wow, okay, so I literally just did it wrong. Sick. You love to see it. Okay, we're gonna skip edges for now. Because, like, I really want to run this and, like, watch it fail. Oh, okay. I gotta get rid of these. Ugh. God, it's already hot. I'm gonna open a window. Multiple window. Okay. So we're actually not doing this here. It's a very simple calculation. It would just be why don't I do it right now? So it's distance. Well, I guess it's d. No, yeah, we'll call it d. N dot diff minus d, and that's it. Number system. Urgh. What did I do to optimize this guy? I see. It was undirected. Okay. Okay, so do I care if it's directed? Yes, because the cross product has to point in. It has to be above the surface or below or something. Vert edges. What this? Cross edge N. Okay, so that's like directed edge N. Okay, so this is doing something else. Yeah, okay, I'm just gonna... So we can skip the face if any edge tests fail. If the test point is behind any of the planes that define the column above the face, the perpendicular column, then it can instantly fail. So we can hot fail out of this loop, like continue. That's hot. So did I use a D value? We need a directed. So I need to do this calculation, but I also need these values. I guess I'll just do it slow. Just keep them both. Hush, 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 hush. So what does this do? N cross edge N. So directed edge N should be directed away. No, should be directed clockwise around the face. But like I wouldn't do it any other way, right? With the face pointing up, it's got to be like clockwise around the face. Oh, that's counterclockwise. I'm dummy. Okay, I have no idea. And there's no documentation. It could go right here. It could document whether it's clockwise or counterclockwise. Ah! Oh, here, I guess. List directed edges listed going clockwise when looking in the direction of the face normal. Edit this documentation if this is wrong. We got a 50-50 chance that is right. Okay, and then edge faces. Oh. Oh, please. Oh. Okay, left, right, bottom, top. I guess this actually is undirected, so Face edges. Oh, we got the D value. That's right. Let's go D value. We don't need a diff? But what about mesh? Oh, it's the V. Okay, so that's mesh 0V, but then it's also test point minus D. That's confusing. So it should be relative position plus mesh 0, and then the D value is world space relative to mesh 1. That's not great. Diff cross. So that's a 3, and it has a dot with itself. Okay, so let's do this test. So assuming, wait, n equals n. So this is the boundary. If so relative position plus M0V minus EV0 oh, so we want like times 2 dot product type. Because these are working together. Gonna get the average position. This is extra work, but so all we need to do is test if this diff dotted with the boundary subtracted. It's confusing. If dot, oh please, boundary n. I guess we usually do this way. Boundary n dot. So this is like testing ND for the boundary face, the constructed face of, that's part of the perpendicular column. So if it's less, then continue, I guess, and then maybe it'll be incorrect. The test point is outside the faces, I guess, Voronoi column would be a decent way to put it. Oi. Oh, it's not got. Nobody got it. Okay, this is freaking ID then. Gabbly gabbly. Okay. Yeah, no, that's okay. That's. We want these guys. Oh well. Just grab them. Mystery. Okay, so minus. Okay. Wait. I could totally just do that in one go. Is negative. I think I did it wrong. And this is the way, so. Okay. Yeah. It's not good coffee. Distance squared. So this is already a big accurate number. Self multiply and then wrap. I don't know, man. I don't know if that makes sense. Oh. It'd be more correct to not wrap. Okay, that's probably wrong, but let's invert the algorithm and hope for the best. That is a lot of queries. Oh, not rename symbol. That could have been bad. Wait. Wait. What the? Oh. It should always be 0, 1. Okay, this is rename symbol. Okay. Then we need to change these. I still don't understand it. Plus this minus mesh 1. Do I just move this? I think that might be times 2. I think that making sense. So up here, the vert edges, this is correct, and then this is not correct. So I think it's actually M1V minus relative minus EV0. Because then they're both minus EV0. And relative adds to mesh 0, and this is a mesh 0, so little dose of clarity. It's nice every once in a while. Okay, did I finish? Yeah. All right, let's watch it not work. Strafe, strafe, strafe. Cargo build release. Cool. Uh-huh. Yep. And you fall to the ground. Can you hit anything? No. Unimplemented is point in mesh called. Yes. So that happens when you teleport. And that's fine. Wait, it was hitting something. Wait. The algorithm does not always fail? Why can't I hit anything then? Well, this is going to be hell to debug. Let's look at the tests. So probably a couple of these will pass, but I expect failures across the board. $20 failed. Cool. How nice it is to have tests. So if I wanted this to work, I would need to make all the tests pass. Also, there's a failure case. To do alternate oven searches 90 vertex searches to improve the robustness in the bipyramid failure case. So if you have two tall bipyramids and you start the algorithm on the two farthest vertices, well, you need to. In any case, okay, I guess what you could do is you could have a ball with cones on top and on the bottom, and then if you start, well, that still works. Okay, if you have a point versus a tall bipyramid, and you start on the opposite side, it will not traverse over because it goes farther away in the in-between step. You would need to like just scan a little bit. There's a failure case. Trust me, there's a failure case. Good. I might not even need the guess. Cool. Well, I wrote code that doesn't work. Great. Well, that's progress for the week. I really want to work on the Roblox DOM, but I needed to get some like actual progress done. So I used the most productive moment of the day to brute force some physics progress. Okay, so now I want to try to make this code better, probably by moving it back to where it used to be. So let's look for a giant red. Okay, so yeah, this, okay. Yeah, let's try that. So new prop info, get or create. It do be doing like that. Oh, but I need the quick returns. I guess I can like triple closure it. Where does it go? So it is at that level. I need to like drop these functions that just have 8 arguments. You never want to do that. but I don't know how to get the code in the right spot. And like, it'd be nice to have this code in a similar position to where it used to be. Yeah, actually, I don't know. I guess I'll just try the other way. So this guy is supposed to be here. And this guy is supposed to be here. And then we can merge cow. Oof. And then merge prop 5. This is not going to be happy. So what are the other, what the hell going on? Somebody, why are you purple? Okay, I gotta check the pull requests. Zero copy reflection, so that's cow. Slice readers, decompressed chunks. Okay, so that's not crazy. So it's database cow. So anywhere there used to be cow, it will not be cow. Yeah. Wait, what? Wait, that was it? This is a build? There's no way. Oh yeah. Very close. Okay, that's a troll. That is also a troll. Can you quit trolling? That's going away. Oh look, all the trolls are gone. Okay, and then only these are left. So, oh. Yeah. We don't do that around these parts. Stir as stir. Okay. Pretty sure we can do it like this. Cool. Okay. So then we have fixes. And then we can do the big one. So we want left, but also right. Ooh boy. Yeah. None like that. Like this. Huh. So we got that anyways. So we need the full new stuff. Why is that a conflict? Okay. Continue. Where are we using hash set? Feel like we don't need hash set, but we'll see. Yeah, okay. Mm-hmm. Whoa. Okay, there's no way this builds. It's too complicated of a change. DB stir. Okay. We can add that. Actually, we only need it for DOM. It doesn't actually matter. Oh. So it is a DB lifetime, but we don't need it for DB lifetimes. What up? Is this real? Really? Stir. Very not real. So this is just obvious now. The size cannot be known at compile time. What? B size? Do we need B? Okay, B, reference to B. Wait, does this not have a question mark sized? Oh no. Okay, I see. F returns a B. And it wants a reference to B. Okay, so it should work. You good? Well, only 10 lines of code. I'll figure it out later. All right, let's see if it works. I suspect it is not going to work. That's what I think. That rebase did not take a long time. Oh, yeah, no, it doesn't build. I have to go into the binary one. It works. Huh. Wow. That was easy. Okay. Well, let's benchmark it. Master branch, cargo bench, bin. And then let's see if the performance is identical. It should be very close, like within noise. I suspect that there could be a second serializer performance issue, though, where it's not quite to parity. We might see that. So previously, the lifetime rewrite was 40% slower to serialize because of all the extra hashing work it was doing. So I fixed that, and it actually made the master branch faster. Well, I guess it's not merged, and it's kind of a bad piece. It's bad code. It needs to be reworked, but like it's 37% faster, so probably that's worth it to figure out. But what I'm hoping for right here is that by rebasing on top of that, this code will also be the same speed. It won't have a performance penalty for dropping Euster. Let's look at the files. So this is all dumb weak. And what about up here? Binary, binary, binary. Okay. So I should be able to just... Do I have that in a single comment? Yeah, I do. Okay, so this can go here. Oh, I have to do this. How you doing? Hoocha! Cool. So now we want to benchmark this. So this is week. Like that. Let's check Clippy. Probably still hates the giant function names. Yeah. Okay, so we got some intos going on. Let's try those. Let's see. So can't do that. Cool. Brilliant. God, it's insane that this passes all the tests. So many little bits. Well, cargo bench. Well, I really hope that it's not 40% slower. It's probably no longer 40% slower. I'm hoping to see no change, no change, no change, no change, or faster. Of course, faster would be better, but no performance penalty for dropping a depend. Whoa! Oh, I'm benching against master. I'm doing it wrong. Hold on. Get checkout. Prop info 5. We got a bench here because this is what we're comparing against. So we get to see the big green numbers here again. Get to see how much faster this code is. And then we'll see. That's a good sign. We'll see if the other branch is slower after this runs. I'll be right back. Hyper complex. You're talking about quaternions? Or are you talking about how complicated the code is? Look at my green numbers. Green is good. Ooh, it's Friday. Yeah, show me those green numbers. sure. I'm curious what you actually meant. That benchmark is unreliable. It randomly gets 70% slower and faster. Jeez. Woof. 40%. Sheesh. Okay. So, this is what we're up against. Quaternions is relatively rare. Almost nobody knows about it. Okay, so you were talking about quaternions. Well, I wasn't sure. I assumed I had to like check to see if you were talking about it, because like, yeah, it is really rare to know about quaternions. Okay, so let's check out the what is it, lifetimes, and run those benchmarks. And what I'm hoping for is like moderately, like very similar performance. I want like not regressed, basically. So I want less than 5% penalty. %. Okay. It's a good start compared to the 40% penalty that it had before. Just realize it's faster. I'm not using quaternions in my new game engine yet, despite my namesake. I don't know if I will either, because, well, maybe... I don't know. Look at that! So this used to be 40% slower. And now it's faster than Master Branch and identical to the improved performance pull request. Oh no! Minus 20. 7. Plus 27. No. We don't care about this one. It's unreliable. This is the most important one right here. That's running right now. This upcoming result. If this also says plus 27, then it's pretty much failed. Okay, so that's what I said at the start, is that I think there might be another performance issue, but I mean, it should still be faster than the Master Branch, because with the performance enhancement, it's 40% faster and then 23% slower. Quentins. I have not heard of that. Oh, quaternions. Internally, many implementations use it. What do you mean internally? Wouldn't it be the exposed implementation? You wouldn't like implement quaternions internally and then have a matrix interface, and then you like always have to convert. Hash map. It's the hash. Is there more bad? Why is it so bad? Is this a complete? Oh, right. I see. Okay. Damn, I can't believe it passes all the tests. It's nuts. This is old code at this point. From the Stone Age 3 weeks ago. Euler angles is more easy to get by humans. Well, that makes perfect sense because like your head is Euler angles. You like always keep your eyes parallel to the horizon. And you wouldn't use quaternions for like a camera. Euler angles makes more sense. Like unless you're making like a space game, then maybe. I like the implementation artifact where like if you move your mouse in a circle, you'll like rotate. Is it the opposite direction? You'll like rotate your coordinate frame. Roll. Okay, you know what? Let's test against master. I want to see green numbers across the board after we do the baseline benchmark. What are you benchmarking? So this is a library to read Roblox files. So it's this library. It's written in Rust, and I am using it for many of my tools and projects because I have a Roblox game. I guess I shouldn't run the game while the benchmarks are going. Yeah, I have a game on Roblox, but I don't want to invest my life into Roblox. I want to get away from Roblox, and so Rust is really cool. What if I made a game in Rust? And so I'm doing that. I'm making a game in Rust, but the thing I'm benchmarking, I'm kind of on a tangent, not directly working on the game. I'm working on the library that I'm using that's open source and improving it because I can see room for improvement. I'm not very good at submitting high quality code though. I finally got a performance improvement in my latest and greatest of my many pull requests. I'm probably kind of annoying. Author. So there's 22 pull requests total, and I have submitted 15 of them. Yeah. So yeah, I'm working on an open source library. As kind of a side project. Oh, dude, imagine how all the numbers are going to look. This is the unreliable benchmark. Brilliant. All right, the last one, and then the baseline is done. All right, check out lifetimes, run those benchmarks, get her done. Do you really need Rust, or is it just inspiration? It's preference. So I think Rust is great. That's why I'm making a game in Rust. If I wanted to like make money or like make a game fast, or if I had some other goal, it would be big number. It'd be better to like use a game engine and like just go ham on that. But I want to make a game engine. Like that is my goal. Is I want to make a standalone game, and I don't really use libraries much. So so of course making a game engine in C++, there's a lot more libraries you can use that are mature and like support the creation of the game engine, but I don't know what those libraries are. And that's kind of my way, is to just make everything myself. So if I'm just making everything myself anyways, then let's use Rust, my new favorite programming language. Yeah, so it's going great. Very, very slow going, but it's doing. All right, here's the unreliable benchmark. Here's the important one. What is most painful in Rust? Painful. I would say learning the language. Probably the learning curve is one of the steepest of any languages. Rust makes writing complicated code easy. But you can't use it unless you know how to use it. It's a rather complicated tool. Yeah, I think learning is the hardest part. Wrapping your head around like lifetimes is pretty wild. But lifetimes are programming. They exactly model the concept. They're one-to-one. So if you don't know what lifetimes are, you're going to be writing bugs all the time. So it's like learning Rust teaches you like real programming. It's so yeah, I've gained so much by learning Rust, but it was definitely harder to learn than like Python or something. Okay, wow. Big up numbers. Yeah. Okay, so I'm gonna cross out these lines. How do you do that? Oh, you don't. Oh, I need to add the dependencies. Rust was fancy for small programs. Yeah, it's definitely more verbose than stuff like Python. Audio effects. I've always thought it'd be cool to do audio on the GPU. What about the one before this? It was minus 18. Behind. Classical DSP is not computationally complicated on PC. Oh, I meant like for games like reverb, like a volumetric sound, like actually computing sound propagation and stuff. You use like ray tracing. Just a cool idea. No way, it sounds like real life. I mean, I have good headphones, like. So I like good audio. Um uh Rendering virtual environment. I wonder if you could like reuse some of the what are they called, like light probes. I wonder if you could use the same light probes that you do for ray tracing for sound, and you could like approximate the scene topology, the scene geometry, and how sound propagates using like light probes. Well, okay, I guess it's more based on connect. There's not like a continuous sound source like you have with light. So that the light probes are more like equilibrium, finding equilibrium of like flux, light flux. Whereas sound is more like connectivity. And then like you have to sort of kind of do propagation on the fly. I don't know. It's an interesting idea though. You could definitely use ray tracing to make effects, sound effects. Okay, there's 3 commas in this sentence. After rebasing this top of 5.4, this PR is 17% faster than the master branch in both serializing and deserialization. Period. However, it is 18% behind 544 without this on top. So there may be another improvement. Okay, that's better. It exists. Physically motivated rendering. You mean like sound rendering, and it still sound artificial? Yeah, I would expect that. I've seen that before. I remember seeing a video. Someone made like a voxel sound engine. I also love vibrational modes, vibrational analysis. Using that, I've seen like 2-minute papers where they have like crinkly wrappers and stuff. That's really fun. Ten-minute papers. Performance win and memory control benefit. May or may not keep looking into strong types. Since it seems like there could be a lot of serialization and deserialization advantages. Big line of code. Really? Is it actually 17% faster? Damn. Gotta go to sleep. All right. See ya. I'll stream again on Monday. I'm streaming Monday to Friday. See you around. This is... This like belongs somewhere else. Why is this deserialization faster? What the hell? Deserializer state. We take those. A spider. Your job is to eat bugs and not be seen by me, sir. Yes, I'm coming for you. Ooh, almost got you. Anybody who doesn't like spiders, look away now. Little guy? A little bit big, actually. Alright. He's going off the balcony. That's like 3 spiders I found in 3 days. I definitely have many spiders in my house. I didn't used to. There's like cobwebs all around the floorboards. I am so lazy when it comes to cleaning. I cleaned them out once, but they're back. It's only been a problem for like a year. And I've been living here for like 4 or 5 years. Let's do a before and after. Lifetimes one. Benesh. So this is before the performance changes. Close with comment button. Gives anxiety. I see. I mean, you can just reopen it, so. You know what? I wonder if this thing writes down your like kernel version when it does the benchmarks. And then if you update your computer, it goes, oh, those old benchmarks are no longer relevant, and it'll not show the performance difference until you run a second benchmark. I wonder if that's why sometimes there's no difference to the last benchmark, or if it's purely time based of like, oh, those benchmarks were 3 weeks ago. Whoa, the old one is bad. Let's see those green numbers. Ooh, we're gonna get it. Are we actually gonna get a 2x off of that? Let's go. Okay. Check out lifetimes and bench. Give me all the green numbers. I want to report that it's 100% faster. It's 2 times faster. I fixed it. I fixed it. Remember that problem? It's resolved. It is no longer a problem. I solved the problem. No need to worry. The problem is solved. You may have noticed that there was a problem, but worry no more. Worry not. All right, how we doing? Nice. Yes. Nice, nice. All right, all right, all right, all right. Okay, okay. Pretty good, pretty good. This one is unreliable. We don't care. This is the important one. I want to see that minus 50%. Let's see it. Oh, ooh, there it is. I might do it the other way around. And then do we get a bump on this as well? What? Okay, was it because I was screenshotting and stuff? I don't know. But we take those. Number 544, number 544, number 544. I should probably... Oof. No, I mistyped it. Oh my god. Should be the same. Oh, I know why. So the deserializer improvement, I believe it comes from the dependency pull requests. All right. Get wrecked, serializer performance issue. Hello, YouTube chatter. Hooray! Are we getting some cheese all day? I got other words English? I already ate cheese, so you're too late. Couldn't possibly have more. What's oof? Oh, that's under the camera, isn't it? We got the lots of changes. Oh, I have to edit these, don't I? Oh. I just push this and I'm chilling. Hell yeah. I'm a gamer. Let me check. So let's go. Oh, get checkout master. Cargo bench Benech. Let's check the prerequisite. This is prerequisites to. I think that those are giving the performance boost. Oh, hi. What is that? Oh, looks like it. Oh no, this is versus the other branch. Never mind. This is the we're doing the baseline. Okay, I suspect that the performance uplift is from the dependencies, but I don't know. So I'm going to test it. Let's see. Yes. Okay, so we're gonna go to the prereq branch and do benchmarks. Yes. Give me the green numbers, the green numbers. Huge. So we should see like similar numbers to the overall changes, maybe. So this one is particularly strong, I think. Was it like 40%? Sheesh. Okay, so why did it say 17%? Is this going to say 17%? It might. Looks more like 6%. 0. What? What? So the performance. What? Am I going to see a plus 17% on the Miners Haven deserialized benchmark? Yeah, this is unfortunate, but it's still faster than Master. Right, that one's unreliable. Okay, if the deserialize shows slower, then how did I get plus 17%? So that's the serialize. We know that one's slower. A second bug has been found in the serializer. Well, there might be another bug. 22. Didn't it used to be 29? Okay. Well, good thing I tested. Okay. Boof! 2x! You'll love to see it. All right. I roasted the performance issue. Absolutely roasted and toasted. Rolled and smoked. I could potentially find another issue, but it's probably not as obvious, or it's a collection of smaller issues. How's it going? I've done two things already. So I wrote a bit more physics stuff. I just like continued from where I left off and tested it, and it didn't work. And I'm like, whatever, I'll just do it next week. And then I rebased yesterday's changes. No, I rebased the drop Euster pull request on top of yesterday's changes. Yeah. And it fixed the problem. So in this pull request, I was like, oh, here's my proposal, but it's slow for some reason. I don't understand why. I fixed it because of yesterday's pull request. Which was my intention. That's why I was working on it, because, well, multiple reasons. One, I thought that I could improve the serializer despite this pull request probably not going upstream. So it would literally just be a pure benefit. But then also I could prove that this wasn't causing the issue. It was just making bigger an issue that already existed. Magnifying. Why does GitHub do that? Cool. Okay. So they don't like these changes, and honestly, I agree. It's kind of nasty to add like cross library lifetimes to your objects. But the memory control is better than Euster. So I proved that this is a purely memory change, memory improvement. Apparently, it's also a performance win, which, like, okay, I guess we get performance from that. Okay. Very big. Very, very, very big, yes. Indeed. Great. That was basically what I wanted to do today. I wanted to like give the physics a poke and rebase this onto yesterday's changes, and I did that. Now I'm thinking about strong types. Those would be so good for serialization. You would just go like, and it would just go straight from the data type to the file. That's it, and then you're done. No way. And you don't need migration because the strong types change according to the whatever Roblox is doing at the moment. And then the migration happens on deserialize. So you deserialize into the most up-to-date types, and then when you serialize, you don't know about any migrations, and it's impossible to change it's impossible to write to the strong types incorrectly in a safe way, because Rust and because structs, because strong types. Hello, what are we doing here? I'm stalling for 3 hours so I can reach my streaming quota, my imaginary quota that I made up of I have to stream for 3 hours. All right, it's time for B-Hop. I did the work. I did the stuff that I was going to do. Oh, no. Oh, it's a Flatpak update. Flapjack. That one. Do it. Do it. 300 gigabytes. Oh, right. I updated my GPU drivers. That's why. Big updates. Let's go. Open the game. All right. Can I win? Oh my God. That is far. But doable. That's probably the world record out. I am not sure if I want to grind this map. Why is it so wide? There's probably someone with a super wide name in here. Let's see. How am I doing? I'm at 146. I am faster than that now. Look at how fast I am. Oh my God, I'm so fast. Oh my God, I'm gonna make it. You! Okay, but then what do you do here? I'm so fast. Whoa, speed. Is there a platform there? Ah. That wouldn't have beat my time. I did fail. Alright, maybe I'll give it a little grind. We'll get a little bit better time on this map. Oh, performance win. You don't make that. Whatever. I'll just go slow way. It's fine. I gotta do that anyways. Damn. Damn. Does that, like, get in the way? Oh my God. Quad GUI system. Man. Ooh, that's frighteningly far. I don't know if I can make that even with top gain. The best gain I can muster. I'm just gonna go with the new broat. Oh. What? Did I hit the wall? I guess I'd go for that. I guess I could paint. Just feels like cheating. Yeah. Okay. Around and around. Okay. Go around. Woo! Okay. Ah! Oh my god, almost got it. That would have been in. That's good. That's good. I think I go that route. That seems like a W. That might be like another 29. Or maybe that's like 28. I wasn't looking at the time. It's crazy how I'm faster. I'm better. Oh, I could totally take that corner harder. Cut that corner. Cut that corner. Cut that corner. It's so smooth. I love smooth games. You hear? Okay, where am I going? Okay, I'm just gonna stay on this track. Okay. Okay. Oh, wait, what? What did I do before? So I went here. I swear I was like aiming for this and then I would have gone there. So I hit here, here. So do I go for there? That looked very far. I don't know what happened. I'll just try again. I've only been going for like 5 minutes, so should be easy to, or 10 minutes? 7 minutes. Go, speed fast, fast speed go. Yeah. Close. I could have hit that if I was better. I had the speed, I just didn't have the motion. The aim. The foresight. Dice. I think I might hit a 27 on this if I get a good run, which like very cool. Yeah. Yeah. Gain a bit too much speed to hit it like that. Is that a -1 actually? No. I don't know. I'm like on the wrong side of the Maybe I cross. Maybe I cross over after I gain a bunch. Not the greatest setup. Oh, I love this game. I missed it so much when I couldn't play it. I was like, oh, I want to play B-Hop, but I don't want to spend a minute booting Windows. It's annoying. I can't be asked to do that. Oh boy. I've lost some gain here. Can't seem to hit the fast route. Can I go faster? Okay, we're on that side. I see. It's hard to visualize. I can totally gain like a fraction of a jump there. I don't think I'm gonna go for it at this moment. I want a 27. Because it changes the whole route. I'm already en route. Okay, that's good. Okay, well that's fine. I'll just hit it. I didn't cut it good enough. I don't know if I had the speed to do the route I want though. I really need pristine gain all the way to the end. Nice. Oh, okay. Saw that coming. And did nothing about it. Classic. Nice. Yeah, it's the mouse lifts really are lost opportunity. If only I had a mouse pad that was 2 times bigger. And an arm that was 2 times bigger. Okay. I like how my gain keeps getting better throughout the session. It's fun. Ah. All right, I'm gonna try for it. Oh. Oh. Yeah, that's hard to change route in the middle of grind. First time I hit that though. Actually, I don't know that. I might have hit it before. Oh, this is fast. What the hell was that? That was like a good bit faster than usual. This is a good bit slower than usual. Gotta make up for it with gain. Didn't quite get it. Stretching that gap is what kills you when you like have to make the split-second decision to go to the farther platform than the last time you did a jump. Okay, this is quite fast. Very, very, very good. Okay, I totally can hit the middle platform now. I think it's about the same. I think that's the route that I have to go for to hit the end because it seems really far. So I just have to do that again and land. Stick the landing. Oh, this is not it. Decent. Okay. Decent. Okay. Yeah, just didn't have that extra little bit. Did you see the cross? I did the cross. Properly set it up in my mind. Nice. Make that. Yeah. Nice. 2, 3 here. Middle, middle, middle. Damn. Do get 28 off that. That's 211? Wait, what? Wait, what? Is it that bad? I'm like, I thought I was like here. Oh, there's a lot of 28s. Oh, okay, I've got to beat this. This is like one of my worst times then. I did not realize it was that bad. Oh, yes. Very speed. Oh. Little bit of a fumble. Okay, middle, 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 far, far. Yeah! Yes, 116. Usually, that usually means I can get better. Right beside the long name, dude. So I really go like wide and winding at the start. What is okay, the world record is gonna be insane. There's no way I can do this. Like this is gonna go straight to the oh no it doesn't. Third. Okay, saves a jump there. Saves another jump there. So that's -2 immediately off of my run. Wait, I got 27. So that's only like -1. Wait, my time is actually pretty good. 0.7. No, that's a whole -2. That's probably mostly at the beginning. Yep, the beginning is big gain times. That's it has the most impact on the rest of the run. That is just very far. And serverless. That's good, I think. I got my B-hop fix. That was nice. Oh, I never showed the audio guy in my actual game engine. I guess they went to bed. Yeah, so next week we'll be fixing these tests. And once the tests run, then probably the algorithm is good. Apparently, there is a case where it can work. No, push solve, never mind. Okay, so the hit nothing works. Okay, literally, it doesn't work. The algorithm literally does not work. Cool, okay, nice. Okay. That's fair. It's fresh new code, but I have tests. I could test it. Buh. Yeah. You know what? I'm gonna do it. Let's look at strong. How should it be done? Strong. Wow, it's instances. So basically every single instance will have its own serializer. Oh, will I need vac? La 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 la. Yo, wait. I could make the biggest struct the world has ever seen. Well, that's not true. It would be 500. How many variants is there here? Let's see, -8. There is 802 times 24 bytes. I don't know what that number is, but it would be a big number. So I would track every single type of instance. Parent. Where's instance? Oh my god. Okay, it's gonna be like, we can find it here. Okay, cool. Object. Does it not have parent? So we need parent referent children vec. Box. This is a dangerous game to get into. I could be working on this for a month. It'd be fun. I would have a good time. It'd be fun. Oh, hold up. I had a comment about what the hell? The stream is in 480p. This is before that. Okay, found it. Okay. Another comment. After reworking the serializer, seems like there could be a lot of serialization and deserialization advantages to using strong types. Notably, migration is completely unnecessary during serialization because the strong types are locked to a specific database version. Oh my god, my spelling is immaculate. Wow, only one. Only one typo. Wow. I totally expected to look over and see like everything spelled wrong. I mean, that's not that big a deal. So what about deserialization? I'll just edit this. It's not worth anyone. Or maybe I should just say serialization advantages. Yeah, there's no edge cases. It's just better. God, after I do things, I like comment everywhere. I'm such a goober. All right, did I reach my quota? Yep, 3 hours and 2 minutes. It's pizza time. It's pizza time. Ooh, that's a fun song. That's the way. The dance. What? Goofy dance. I was thinking just of like taking a look at strong types. But like I was wanting to work on like a strong types serializer. But the thing is, you need a deserializer first. Otherwise, there's no such thing. The serializer, I don't think benefits that much from strong types. You still have to do all the migrations from whatever junk is in the file. And the migrations are largely based around the variant paradigm, which is fair. It kind of needs to be. Oh. What if you did the migrations in place on the object? Oh, but then you would it would need to. Okay, never mind. Okay. Buh. My brain is just going crazy. I'm thinking about like, what if you have a cow that has boxed, borrowed, and borrow mutable, and there's like 3 ways of doing it, but then it's not an enum. Instead, you're like templating somehow, but then that's tough. How do you do that? I guess it would be a macro, and then there have to be different types, and it would suck. You have to match, you have to convert, but yeah, because you need to match out every time you convert. How do you make the overhead not happen? Ugh. I think it's fine to just have a mutable reference to a boxed type, enum of a box type. It's a double reference, but like that's makes it so much easier to do. But then if you have a list of the same type, considerations. So I think the serialization goes super hard with strong types, but the deserialization is kind of bojangled. So like if there was no migration, it'd be like, yeah, let's go. Huh. Move. That's copy. But you have to do that. God, the Roblox format, man. Oh, you have to do that with. Ugh, there's so many like additional copy stages. You need like 3 separate stages with 2 copies, both when you serialize and deserialize, just because of the way it is. So silly. Okay, what if you had what if you built so you have like a interleaved iterator builder or something where it's like, I know that this is interleaved, but I'm not going to like copy the data, mutate it into another copy, and then give the values. I'm going to just hold the original and then read out the 4 bytes directly when it's needed straight into the struct. Can you do that? I think that might actually work. Sounds fast. No copies, only one copy. So you have to bypass the interleaved stuff. Okay, now that is interesting. Okay, what the hell? What the hell is this? So, if we go into the code, it's phenomenal that I can just see it in my head. Love it. Deserializer. It's actually core. So, I'm talking about the interleaved bytes. So, there's an n here. And n is 4, basically. So it's like taking len values, and they're like floats, so that they have 4 bytes. So each one of these is a float. And then it like writes the first byte of every float first, the second byte of every float second of your list of floats, the third byte next, and the fourth byte finally. So it's interleaved the float bytes. And CLV says that's better for compression. I would believe that. So then when you read it out, it's like, this is read. Yeah, it copies it into a buffer. It copies it again into the output, and then it copies it again into this vec. It copies it again. Oh my god. Oh, I forgot about this, but that's fine. That can be done once. Like, bro, 4 copies, really? So I think I can get it down to 1 copy, but it has to be like monomorphized for the type. But like this is monomorphized already. So I can read the first byte for the first float, the second, the like first, second, third, and fourth byte for the first float, and then I can read the first, second, third, fourth byte for the second float, and like pull those out. Yeah, because I have a decompressed chunk. I think this works. So then the idea would be that you would decompress all the chunks, construct iterators, and pull everything you need and stuff it straight into the final type and add it to the tree. And I think that would be like 5 times faster than this library. Because, 4 fewer copies, strong types, no hash maps. Oh, you still use a hash map for the tree. Cool. So that's like fast deserialize. And then serialize, I already explored how that's faster. This is so dangerous. I'm going to spend a month doing this, man. Should I just make my own library? Make your own library. I kind of want to. Can you plumb features from sub-libraries? Like you can say, oh, if we have this feature, then we use that feature. This got to be, right? That just seems like the way. Because then you could have RBX DOM, and they could be weak and strong. And you have RBX binary, and you can have weak and strong features. I don't know if that's the best way to do it. RBX fast binary. Strong. Yeah. What do we want? No more of this. Don't. Bad. So it would decode the chunk, hold a slice, or decompress the chunk. It has to do that. So you have the full chunk as a slice, grab the slice that has the interleaved bytes, and then just in an iterator. And it's gaming. It just does it. It's easy. Like it doesn't have to, it doesn't have to be an iterator. You could totally like say I and like U size. Can you F? Wait a second. You could totally do that to write as well. You have to fold it into the. You have to. Think. So right. Where is right? Hello? It's up here. What? There's read. Right. Wow. Okay. So the type signature is right. Of right. Oh. Never mind. It doesn't work. Well, you can. I don't know. Which is faster? Looping over a list of references and you like take the name property, then you take the size property, then you take the C-frame property, and you have to loop the list every single time. Or do you hold all the prop chunk constructors at once and do a big... Yeah, no, okay, it's just a transposition. Okay, no, it's bad data locality no matter what. You're always doing a transposition. It's just whether you do XY or YX. Probably one of them is better, but you can totally write it out in a consistent... Wait. Isn't that what this... type info. Wait a minute. Type infos. Values B tree map. It's literally doing that already. So literally this becomes a struct of vec of reference to strong type. And then it's just a 500-mile long struct of vecs. And then you literally, it's just hard coded, and it just goes down and uses the serializer for each one. And that's it. There's no, it's just an absolute ton of code generation. I wonder how big the binary would end up. It probably would be like 10 megabytes or something at worst. Actually, how big is it now? You gotta unban me. That's up to the moderators. You talk to the moderators if you want that. I don't do any moderation at all. I am a programmer. I'm not a moderator. Disk usage. Target release. RBX. Binary. Oh, hold on. That's the type of thing a lazy person would say. I'm not qualified. Like, I don't do moderation every day and have a good idea of who's cheating and who's not cheating. I'm literally not qualified to do it. Earl. Lib. Okay. rlib. Is that correct? 1.5 megabytes. Small. Not that small. If this was C, it'd be like 300K. Oh, I could use my my hacks. This guy. Oh, is it at the top level? All right. I'm set to be unblacklisted. That's great. If that's true, then you should be able to go to the moderators. You realize you're an untrustworthy source of information, right? It's slightly smaller, huh? What about this one? I'm curious. Same size. Sylvia is an admin. That is just not self-aware. Maybe I should try to do it. Builder, 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 builder. Right. Read and write are like bad. Core. Chunk. Chunk. Do we have... Buffer. Yeah, so write is bad because it requires that to already exist. Hmm. Ugh. Back. Gosh. Yeah, the whole thing just reeks of like reallocation and copies and so much copy, copy, copy. It could probably be like twice as fast. Oh, I guess you don't need to do it all in one go. Probably. Oh, I see. They're different. Yeah, so you should have an enum. Hmm. I just want to rewrite it. The whole thing. Ah, I'm in so deep. No, I'm so invested. Okay, I told you what to do. CLV also told you you would send a message. You're done. Man, this is gonna haunt my dreams. Oh, strong types. I need to get back to the physics. Ugh. It could be better. Can make it better. We can read Roblox files in 50 milliseconds instead of 150 milliseconds. Ugh. I'm not trying to do a voice call. I can see the messages. You've already got the moderator's attention. Should be resolved, whether that means remain blacklisted or get unblacklisted. It's very not self-aware. All right. Well, I don't think I'll continue today. I got everything I need to do, or that I wanted to do, done. Oh, look, it was resolved. Brilliant. Isn't that nice? Okay. Well, I think I'm going to continue to be haunted by strong types. Especially now that I've got the interleaved bytes reader in my mind. You need to hit the gym. I would rather do programming. Totally going to be thinking about that. Good for your health. Yes, exercise is good. About to hit 40. Damn. Alright, so I'm not sure what I'm going to do on the weekend. Probably just be lazy and relax. Get ready for work on Monday. Your game is dying. It's been dead since 2015. It was already dead when I made it. Okay, that's the end of the stream. See you Monday. Goodbye.